Hello, my little mathematicians. Today we are going to explore box and whisker plots, otherwise known as box plots. Box plots are a display that shows how the values in a data set are distributed or spread out. There's 5 important things that you need to know in order to do a box plot, and that is the minimum, which is the least value in the data set, the maximum, the greatest value in the data set, the median, sometimes referred to as the second quartile, but mainly the median, is found the same way as always. List the numbers from least to greatest and then find the middle number. And then what's new is the lower and upper quartile. The lower quartile, once you have your median, it cuts your data set in half. You have the lower half and the upper half. Okay, so to the left of the median, you want to find the median of that part of the data, and that's your lower quartile. And then here's your median. To the right of it is your upper half of the data set, and you're going to find the median of that. So that's called the upper quartile. And then when you go to graph it, it looks like this. You have a box and whiskers. Okay, so here's your minimum, maximum. There's your median, and then you have your lower and upper quartile. So within the box, like this is the medians of the values of all your data set. So here's your median of the whole set. Here's the median of the lower half. Here's the median of the upper half. So this represents more accurately the true spread of a data set, because in case your minimum, maximum, or both the minimum and the maximum are outliers, the box better represents where the vast majority spread of the data is located. Okay, so I'm going to really quickly show you how to find it. So I'm going to give you 2 data sets. Let's say we have an even amount. So 1, 2, 3. Here's your first data set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then here is your other data set. We'll do an odd amount this time. 1, 2, 3, 4, 5, 6, 7. Okay, so first off, let's find the median of this one. Okay, so first, last, first, last, first, last, first, last, first, last. That just helps me make sure I know where I'm crossing off from, the first part of the data set or the last part of the data set. Okay, I got right here to the middle. So the median is between 5 and 6. Well, what's between 5 and 6? 5.5. So that's my median. And remember, if you have 2 numbers in the middle, to find the average of them, if you can't just figure it out by looking, find the average of those 2 numbers. 5 plus 6 is 11. 11 divided by 2 is 5.5. So now I want to find the median of the lower half. So right here, the 5 is part of the lower, right? So first, last, first, last. There you go. That is the median of the lower half. So that's called the lower quartile. Now I want to find the median of the upper half. And the 6 is not the median. It's part of the upper half. So first, last, first, last. There you go. The 8 is the median of the upper half, or known as the upper quartile. Okay, I said that we needed 5 numbers in order to make up a box and whisker plot. Here's 3. And then the other 2 is the maximum and the minimum. So the smallest and biggest. Those are pretty easy. Okay, in fact, you can even identify them right away from your next data set. You have the minimum and the maximum, right? Okay, now let's find the median. So first, last, first, last, first, last. There is your median value. Now, for this one, 4 is the middle, so it's not part of the lower and it's not part of the upper. So for the lower half, it's just the numbers 1 through 3. So first, last, there you go. There's the median of the lower half, known as the lower quartile. And again, 4 is not part of the lower or upper, so I start right here at 5 to find the median of the upper half. First, last, there you go, upper quartile. So now I have my 1, 2, 3, 4, 5 data values to graph this box and whisker plot. Okay, and what that would look like is, you would draw, again, a dot at your minimum value, a dot at your maximum, a dot of your median, and then your lower and upper quartiles. And then you always, once you do, I always do my, I graph those four things, and then I draw a line down at my median, and then I draw a box around it, and then I draw my two whiskers coming out from it. And that's how your box and whisker plot looks. Okay. Sometimes they might ask you about the measure of spread. The measure of spread is a single number used to describe the spread of data. And so the one we're familiar with is the range. That's the spread of the entire data set, where you take the biggest number minus the smallest, so the maximum minus the minimum. But sometimes if those are outliers, a more accurate, better representation of the spread of the data is to take the interquartile range, or shortened, they usually refer to it as IQR, where you do the upper quartile minus the lower quartile, because that's the median of both the upper and lower half. And so that better depicts how your data is spread out. So if they ever ask you for the IQR, you just take the upper minus the lower quartile. Okay, so let's answer some questions based upon these two box and whisker plots. These box and whisker plots are talking about the price of t-shirts at these two stores. So we have Owl's store, the top graph, will represent him in blue. And then we have Bree's t-shirt store, will represent her with blue. Okay, so green and blue. Whose store has the most expensive t-shirt, and what is that price? Well, the most expensive would probably be the maximum value. So here's 26, this one's 29. So 29 wins, and that's talking about Bree's store. Raking in at 29 bucks for that t-shirt. Okay. Whose store has the greatest range of prices? Okay, well, for the range, we have Bree's store, which the maximum is 26 and the minimum is 17. And when you go 26 minus 17, you get $9. Okay, and then you have, oops, did I just switch them? I totally did, didn't I? Bree's store is actually, or here, okay, 26 minus 17, that's representing Owl. So we'll say Owl store. There you go. Okay, so Owl store is 26 minus 17. Bree's store is this bottom graph. And hers goes all the way from 29 minus the lowest is 18. What's 29 minus 18? That's $11. So who has the greatest range? Bree does. Bree's store at $11. Okay. Whose store has the lower median? Where's the median on a box and whisker plot? It's the one with that line down. It's the center of the box. So this median is 21. This median is 23.5. So who has the lower? Owl store at $21. Whose store has the greatest IQR, or interquartile range? Okay, so Owl's store, his interquartile range is 24 minus 20, because you take the upper quartile minus the lower quartile. So his is $4. Bree's store has an IQR of, well, 26 for the upper quartile and 2150 for the lower quartile. So if you subtract 26 minus 2150, you get $4.50. So who has the greatest IQR? Bree does, just by 50 cents, so just barely, okay? And again, this is handy if you want to analyze things talking about the median. So quickly looking at the data and knowing, okay, like, where's the median located? A box and whisker plot very quickly will give you that data. And then also breaking apart, the minimum and the maximum, and where most of the data set is grouped together. So you can see the box is where the majority of the data within that quartile is where almost all the data is located. Okay. And so that's just a little bit more vocab of how to analyze graphs, and the type of information we want to analyze is when we would want to use a box and whisker plot. Again, if you were asked to describe the spread of the data or easily identify the median, okay? And then especially for comparing different graphs of like where the vast majority is and things. This is helpful when determining grades and looking for like where's the vast majority, because it splits it up into 4 parts. 1, 2, 3, 4. And so actually 100% of the data is all the way across. So if you divide it by 4, what is that? It's 25% of the data is in each group. And so this is why I said the box is really helpful, because 50% of the data is within the box. And then you have the upper 25%, the lower 25%, and then the middle 50 right here within the box. Okay, so again, box and whisker plots are really helpful when describing the breakup of a data, and it kind of groups it together of where the vast majority of your data lies. All right, congratulations, my little mathematicians, at mastering yet another type of graph.